learn for this particular chapter is known as Bernoulli's principle. So, Bernoulli's principle, students, is one of the coolest of all. Bernoulli's principle states this. Now, capital P is pressure, right?
Yes, sir.
Yes, Coach.
Coach Joakim.
So, Bernoulli's principle states as the velocity.
What is that thing?
We'll scoot it over a little bit.
What's the
Upside down T.
We'll see in a second. Here's what Bernoulli's principle states. First of all, this little upside down T represents perpendicular.
Oh.
Remember in math, perpendicular?
Yes, sir.
We have learned that, Coach Joakim.
As the velocity, now this is velocity, and so you won't confuse it with volume, I'll do VEL. Okay, so for this particular chapter, you can't really tell a lowercase v from an uppercase V for handwritten text. So I'll do a VEL for velocity. As the velocity of a fluid increases, okay, the perpendicular pressure of that fluid decreases. That is Bernoulli's principle. As the velocity of a fluid increases, the pressure perpendicular to that velocity decreases.
Is a water gun a good example of that?
Water gun?
Yes, sir.
No.
Coach Joakim, what is perpendicular pressure?
Okay, I'm about to demonstrate right now. All right? Here's the deal. Some of you all have an old-fashioned shower, which has a shower curtain. Your shower may look something like this.
I got one of them.
Change your voice.
That's
All right.
a normal shower, Mr. Judge.
Well, some showers have like actual shower doors. This one's a shower curtain, okay? And you all do know that the water comes down this way, right?
Yes, Coach Joakim.
So what direction would be the velocity of that water? Downwards.
At a 45
Downwards.
degree angle.
Now, before the water's turned on, before any water's flowing at all, there's already pressure here. And there's pressure here.
What causes that pressure, Coach Joakim?
That pressure is caused from the weight of the atmosphere.
Does
Remember-
that change when you place your body in the shower?
Remember we talked about the atmosphere is also a fluid, and as a result, it exerts fluid pressure just as if you're at the bottom of an ocean. We're not at the bottom of an ocean, but we are at the bottom of an ocean of air. And the pressure at the bottom of air, which is at sea level, is about 14.7 psi, 101,300 pascals. Okay? So before the shower is turned on, the pressure inside of the shower equals the pressure outside of the shower. Does that make sense, students?
Yes.
Have I confused anybody so far? Okay? So now you turn the shower on. All right, let's bring the water back. Okay, so now we're going to turn the shower on. Keep in mind the direction of the velocity of the water is this way. So the velocity is pointed downwards. It's traveling downwards, right?
Yes.
Yes, sir.
All right, now what happens, y'all, is this. Originally, the pressure inside of the curtain is equal to the pressure outside of the curtain. And so if the pressure inside of the curtain is equal to the pressure outside of the curtain, that causes an equilibrium of pressure, which keeps the curtain where? In place. Right, y'all?
Yes, sir.
Yes.
All right. Now, if you apply Bernoulli's principle to the shower, as the velocity of the fluid increases, it will decrease the pressure. Notice that the velocity is perpendicular to the pressure on the curtain. Do y'all see that? And so there's a perpendicular relationship between the velocity of the fluid, which is the water and air. You know, the air flows with the water inside of the shower. And so as the air and water flow downwards, the pressure perpendicular to the flow of velocity of water actually decreases. Now watch the smart board demonstrate this. So I'm going to decrease this pressure. So students, what happens on that shower curtain?
It sort of
It
goes
goes
inward.
It goes out. It goes in.
Now you see there's an imbalance of pressure on the curtain, doesn't it?
Yes, sir.
And as a result, what happens to the shower curtain?
It goes in.
The shower curtain turns inward, doesn't it? As a result of the difference in pressure.
I thought if it was the velocity was up, the velocity is down in this one, and then that one, velocity's up. So when the perpendicular pressure would be going up. See?
Okay, just to review, the velocity of the air increased. It went from 0 to something.
All right. I
And
thought it
so
was
the
like
velocity of the
direction.
air increased, which caused a drop in pressure. Okay? So as a result, the curtain draws towards you. Who's experienced that if they actually have a shower curtain? Okay. Does the shower curtain ever blow away from you? No, it draws near you. Okay?
Consider joking. When is this besides the shower? When is this besides inside of the shower? Is it like ever on an airplane or this high pressure situation?
Yes, some would even say that's part of the reason why an airplane flies. Okay? The velocity of the air going above the wing is faster than the velocity of the air going below the wing. So as the velocity, and just to draw that, let me show you what I'm talking about. Here's an airplane. See the airplane?
I do.
Here's the wing. See the wing?
See what I'm saying?
And so what they're saying is the velocity here above the wing is moving faster than the velocity here below the wing. So this one is greater than this one.
And Coach Joking, in the shower example.
Wait. We're on the airplane example right now.
Okay.
Wait, aren't they the same? I don't get how one's.
Now, that's a great question. That will lead to a different debate. There's a deeper debate among scientists as to exactly how the velocity above the wing goes faster. It has to do with the design of the airfoil, the wing itself. So the wing itself is kind of designed to create an aerodynamic effect, increasing the velocity above versus below. Now, once this happens, the pressure acting downwards on the wing is decreased compared to the pressure acting up under the wing. Students, does that make sense? So this pressure right here stays the same. This pressure right here decreases.
Oh.
Y'all got that?
Yep.
So if there's a stronger pressure below the wing than above the wing, what happens?
It's gonna lift.
It creates lift. And that's what it's called in aeronautical engineering. It's called lift.
That makes sense.
Okay? And the only little mystery behind it, Hector, is does the airfoil actually create that difference of velocity above and below, as Anastasia made mention to earlier? Okay. All right. Yes, question.
Is that like the thing with the doors that if you open the door or you,
Yes. Yes. So, students, at this point, I'm going to conclude my review of Bernoulli's principle.
Coach Joachim, I have one more important question.
Thank you very much for your time.
When you're in the shower, in the window, in between the... Never mind, Coach, I remember.
Thank you for your time, students. We'll see you next week in class.
Thank you, Senator.